Hello everyone! For today's video, we're gonna talk about mechanical waves. But to further understand what mechanical waves is, let's have this question first. What is a wave? Waves are transfer of energy from one area to another. The transfer of energy takes place when an energy itself moves from one place to another, causing change to happen in an object. A transfer of energy can also be observed into the different forms such as light, sound, and heat. Waves are also characterized by its frequency, wavelength, amplitude, and velocity. What do we mean by this? When we say frequency, it refers to the number of waves that pass a fixed point in unit time. In other words, it is the number of cycles undergone during 1 unit of time by a body in a periodic motion. Next, wavelength, which means distance between identical points propagated in space or along a wire. It is also related to the frequency by having inverse relationship. Amplitude. It pertains to the height from the center line to a peak or trough of a periodic function. In other words, it is the maximum extent of the vibration or oscillation measured from the position of the equilibrium. Last is velocity. When we say velocity, it is the object's speed and direction of motion. In simpler terms, velocity means the measure of motion is starting in one place and heading toward another place, as well as determining how quickly waves are. Now that you already have an idea about what waves are, let's proceed with our main topic, which is the mechanical waves. Mechanical waves is an oscillation of matter and is responsible for the transfer of energy through a medium. When we say oscillation of matter, it means that it is the process of moving back and forth regularly, while the medium means the substance or material that carries the wave. Here are the examples of mechanical waves: slinky waves, water waves, stadium waves, and jump rope waves. Now, let's move on to the two propagation of mechanical waves. First is the transverse waves. It is the movement of the particles in a perpendicular form to the motion of the energy. As you can see on the illustration, there are crests, which is the points on a wave with a maximum value of upward displacement within a cycle. There is also the what we call trough, which is exactly the opposite of the crest, or in other words, it is the lowest points in a wave or in a cycle. And of course, there is an equilibrium, which is represented by the horizontal line in the middle of the wave. Examples of the transverse waves. Light waves. Light waves because the particles do not move along the wave. They simply move up and down relative to the wave propagation. Strumming of a guitar. As the string vibrates up and down at the right angle to the direction of the wave, it creates transverse waves due to the motion of the strings. Another propagation of the mechanical waves. Longitudinal waves. The movement of the particles are parallel to the motion of the energy. It also produces a rarefaction and compression. When we say rarefaction, the longitudinal wave particles are farthest apart, while compression is a region in a longitudinal wave where the particles are closest together. Examples of longitudinal waves. Sound waves. They are created by the vibration of an object which causes the air surrounding it to vibrate. The vibrating air then causes the human eardrum to vibrate, which the brain interprets as sound. Seismic P waves. They are longitudinal waves that can be transmitted by both solid and liquid materials in the Earth's interior. With P waves, the particles of the medium vibrate in a manner similar to the sound waves. That's the end of this video. Hope you learned something!